Assalamu alaikum. My name is Mohammed Daniel. My roll number is 20E68, and here we are here for lab number 3. As you can see, we are going to first of all discuss about our task. What is impulse sequence? As sequence is to generate the x of f n variable to define it into delta n into n minus 0, and where n1 is less than equal to n and less than equal to n of 2. So impulse sequence defines as the value of n, as you can see here over here. So which will give an accurate result in the impulse form, in a sequence in impulse sequence form, as you can see. So as for it, now we are going to perform our task 1 of lab 3. So here I click, here we go. So as you can see, here is the given function for the impulse sequence, as we have given values 0, minus 5, 5, and we have to plot two subplots. The subplots mean we have to plot two graphs, two on two axes, and on x plane and y plane. So if we run now, so we can see the graph over here, and as you can see, here are the two subplots which I was talking about. Here the first one is the x plot, and one second is the y plot, and we have in the first in the discrete number. So about this, now I'm going to tell you about the step sequence. Step sequence is the discrete sequence we have shown in a function for to generate the variable x in a discrete form. So here is the function of x, where which will be defined by the step sequence, where n minus n naught minus k, where k is the step sequence. We have the addition of k here, which is a step sequence. So after going to the lab task number 2, before going to lab task number 2, I would say that this is the main part which will be discussed in the task 2 of lab 3, which will show our result in a step sequence. And you can see here that for the task 2 of lab 3, which we have given up a plot. After running that, we have two subplots, which is defined in a discrete form. First, the two graph plots, and you can see it over here by plotting them. Now, as we have given value of the for the step sequence 0, minus 5, 5, 3, and for the two subplots we have these values, as you can see over here. So by opening this, we have already opened it, and for the task 3 of lab 3, we can see here that function is defined with the complete code, which will be used in a further which will use for further variables. As you can see, we have given the two n values, n1 and n2, where n1 is equal to minus 5 and n2 is equal to 5, where n is by using the formula where we have n is equal to n1 ratio n2. So it is possible to construct a shifted version of with unit step sequence by summation of the deltas. So in this task, we have to perform the shifted version of it. So by performing it, we will have a result. As you can see over here, we have the discrete values this in a discrete graph, but you can see a difference over here in the subplots by hold and hold function. So as for the now going for the task 4 of lab 3, as you can see, we have defined variable x, which have values 1, 2, 3, 4, 5, which will show us the length of a function, how the length is defined in a function. And we have a title of original signal, which will be shown the original signal and even part of the signal by subplots, as you have heard earlier about what is a subplot, which gives a different graph for each plot. So as we can, after running it, we as you can see here that we have an original signal which has a discrete signal going upward from 0 to 4, and even part of the signal is even part of the and odd part of the signal, which has a reflection of it from y-axis to x-axis, as you can see, or you see it over here by defining it. Now I would tell that now as for the task 5 of lab 3, which is a continuous signal to discrete signal, which in which we have a discrete signal which continuously we having it on a graph. So here we have given a time from 0 to 1, 0 to 2, and we have frequency of 1. After putting the formula of frequency, after giving time frequency signal, time signal, we amplifying signal, and time per period, we have the following graph, as you can see over here, by which we have a continuous time signal and discretized signal. In discretized, we have discrete angles of x and y axis, and that is for the previous one. Now task disk, I would say that we have a unit impulse sequence. We have to find the unit impulse sequence of the function, the signal construction, and a plotting signals. We have to find three signals. As you can see over here, we have different subplots for each one. As x variable is defined, three x variables are defined: x1, x2, and x3 of the values, where x2 is of the impulse, and x3 of an impulse, which we have we using impulse function. Now for if you can see for the code, we have the subplots by adding the hold on function and hold on function by pause to them, or define after defining the function. As you can, after running that, I will show you the graph on the other window. So as you can see here, we have two signals, signal x1 and x2. Just a second, there was an error. By on the now you can see here we have three signals, a signal x1, signal x2, and a signal x3. Each one have a different value for them after for different variables. As you can see it over where for the as amplitude is increasing, and increasing, somewhere is increasing, somewhere is constant, or same for the signal 2, signal x3, same is okay. Each one of them have the different answer. So this is the lab 3 of DSP. So thank you. Allah Hafiz.